All right, today is our sixth and final lesson of our Unit 6. So look at this. We're getting to the end. We're almost there. And we're going to be doing our applications of trigonometry. All right, so we have some word problems. We're going to work our way through our word problems using our trig ratios, which again, if you forgot, are SOHCAHTOA. So let's look at our first question. We have a pirate ship, and it says it's 60 meters away from our lighthouse with an angle of elevation of 22 degrees. How tall is the lighthouse? All right, so what we're trying to solve for is this height. I know it's tough to see there. Let me just move that x. The height, which is x. And we can always assume that the lighthouse and the ground will form a 90-degree angle. So if 22 is the only angle they've given us, we're going to have to label our triangle using that side. So again, across, this would be the opposite side. Crossing the 90-degree angle is our hypotenuse, leaving the bottom to be the adjacent side. So if I'm trying to solve for our opposite, the only other piece of information they're given is the adjacent. And the formula that has an O and an A in it is our tan formula. So then we'll sub those values in for tan. We'll say our tan of 22 is equal to our opposite over adjacent, which is equal to what we're trying to find divided by 60 meters. The opposite of dividing by 60 is multiplying by 60, so that will come to the other side, and we'll get 60 tan of 22 is equal to x. And then when we actually plug that into our calculator, we'll get that height is at roughly 24.2 equals x. So therefore, the lighthouse is 24.2 meters tall. All right, perfect. Let's try another one. All right, so here we got a cat, and the cat is trapped on the top of a tree. And the only way for the cat to come down is to build a slide. All right, and we see here the slide's going to have an angle of 40 degrees. All right, we know that the height of this tree is 2 meters. And what we have to do is we have to find for this side length here. How long is the slide going to have to be for this to work? All right, and we can do this again using the only angle that we're allowed to use, the acute angle here, 40. I'm going to label my triangle. So the side we know, the 2 meters, is our opposite side. The side across from the 90-degree angle is our hypotenuse. And that leaves the base to be the adjacent side. So again, using SOHCAHTOA, I want to find the hypotenuse, and the only other piece of information they've given is the opposite. So the opposite in hypotenuse, that means I have to use the sine formula. So we'll set it up. Sine of 40 degrees equals opposite over hypotenuse, which is equal to 2 meters divided by that length. And again, to find for x, when x is on the bottom, we just swap places. So this becomes x equals 2 divided by sine of 40. When we get that, 2 divided by sine of 40, we're getting x is going to be approximately 3.1 meters. All right, so therefore, the slide will be 3.1 meters long. All right, there's 2 questions we've used solving for side lengths. All right, again, we're just taking information out of the question and solving using our trig ratios. All right. On number 3, we have a hydro pole that is secured to the ground 10 meters away with a guy wire as shown. All right, so we have this 10 meters right here. And then it says, using a device known as a clinometer, a person measures the angle of elevation to the top of the pole. So we can see there's a person right here standing with a wire to the top. And what we're trying to do is we're trying to figure out, all right, what is the length of the wire needed to connect from the ground to the top of this pole? All right, how long is this wire going to need to be? Well, what we can do is we can figure out first how to label our triangle. So here's our 30 degrees. So this side here is my opposite side. This side here is my hypotenuse, and this bottom here is the adjacent. So I'll just solve for L, for the hypotenuse. The only piece of information we have is this 10. Well, A and H in SOHCAHTOA means we have to use cos. So cos of 30 is equal to the adjacent over the hypotenuse, which is equal to 10 divided by, they called it L in the question. And again, to solve for L, we'll rearrange those, get L equals 10 divided by cos of 30. And again, 10 divided by cos of 30, that's going to be 11.5 meters. All right, there's the length of the wire needed. The second thing they ask us to find is how tall is this pole? All right, so I'm just going to erase all the kind of circles I've drawn here. And because I'm using the same angle, this is all going to be the same. But now I need to find this, and I'm going to use the information given. I'm still going to use that 10 meters. Just in case I made a mistake here with my 11.5, I stick to the original question. And the formula that has an O and an A in it would be our tan formula. So the pole, we'll use tan of 30. It's equal to the opposite side over the adjacent side. We're trying to find the opposite side, so we don't know that one. They called it H in the question. And our adjacent side is equal to 10. Then we know we can just move the 10 over to the other side and get 10 tan of 30 equals H. And again, we'll get that the pole is about 5.8 meters tall. All right, there we go. And I think this question, it's been kind of throwing me off. It's meant to say a guy holding a wire as shown, but oh well. You got the gist. Little grammatical mistake there. So here you go, ladder that is 5 meters long is leaning on a window ledge 4 meters above the ground. Right, so here's the ground. There's a ladder set up against the wall. And they're saying, what acute angle does the ladder form with the ground? All right, and we should label our triangle here because they haven't labeled it here. So I'm going to call this A, B, C. So they want us to find this angle here. We don't know what it is, so I'll call it angle B. Well, if that's angle B, that's what we're trying to find. If we label this triangle from that perspective, this is my opposite side. That's my hypotenuse. And this is the adjacent side. Well, the two pieces of information that I need would be the O and the H. Because to find an angle, you need to know both side lengths. So now let's do this. All right, well, what trig ratio has O and H in it? Again, so SOHCAHTOA, that's our sine ratio. So sine of angle B is equal to the opposite over the hypotenuse. So sine of that angle that we're trying to find is equal to 4 over 5, which is just 0.8. And now if I actually figure out what is that going to be, to get that sine to the other side, we have to do the opposite of sine, which would be the inverse of sine of 0.8. And I have to do inverse sine of 0.8. All right, I'm going to get B is equal to 53 degrees. All right, there's the angle that forms with the ground. Now it says, what angle does the ladder form with the wall? Again, do we need to use a trig ratio for this? No. We know two angles, so to find the third, which is angle A in our question, we take 180 and we subtract the other two angles from it. So angle A is equal to 180 degrees minus 90 degrees minus 53 degrees. And when we do that, we get a nice angle A of 37 degrees. And then we're going to solve the triangle, which means they're asking us for the last piece of information, which is the base. So they're asking us to find the adjacent side. How far from the base of the wall is the bottom of the ladder? So they're asking us to find this distance right here. So what we're going to do is let's just mix it up just for the sake of the question. And we need to solve for our adjacent side. And we can use our B value, or B angle again. So if we're using angle B, we need to solve. So we're trying to find this length. We're using angle B, which means I have to pick one other length. And it doesn't matter which one I pick. I'm going to pick the bigger number just because. So I'm going to pick the hypotenuse, which means I have an A and an H, which means we are going to use cos to find that length, right? So it's going to be the cos of angle B is equal to our adjacent over our hypotenuse. We're trying to find the angle. Or sorry, not find the angle. Sorry, find the side length. So angle B, we know, is 53 degrees. The adjacent side, we do not know. And again, I'm just going to call that X because that's what we're trying to find. And the H, the hypotenuse, is equal to 5. So we can solve this by just moving this over to the other side. We get 5 cos of 53 equals X. And when we put that in, we get 3 is equal to X. So then the ladder is 3 meters from the wall. All right, so the math is the same. You're just going to have to apply your skills to some word problems. Hope this went okay. If you have any questions for me, please let me know.